children, welcome to Narayana Digital Classes. Today I will discuss an important topic and interesting one, so listen carefully. So before going to video, just I will ask you one question. So which plane figure has a center? Which plane figure has a center? What is the answer? Obviously it is circle. And another one, does a triangle have a center? Yes or no? Yes. Every triangle has also a center, but it is not one, many. In general, circle has one center, but coming to triangles, it has many centers. Let us see what are the different centers of triangle. Let us see what are the different centers of triangle. First one, see this different centers of triangle. It has, as I said, it has many centers. The first one is centroid of a triangle, incenter of a triangle, excenter of a triangle, circumcenter of a triangle, orthocenter of a triangle, 9-point center of a triangle. How many centers does it has? It has 6 centers. Okay now. So in detail we go one by one. So what is centroid and what is incenter, what is excenter, and so on. So in this video I am going to explain these two centers. One is centroid of a triangle and another one is incenter of a triangle. Let us discuss. So what is centroid? So before centroid, so one see this one point, we have to know point of concurrence. Point of concurrence. What is point of concurrence? If 3 or more lines passes through a common point, such lines are called concurrent lines. That point is called point of concurrency. Point of concurrency. If 3 or more lines passes through a common point, such lines are called concurrent lines, and this point is called point of concurrency. Here coming to centroid, so what is a centroid? Centroid is a point of concurrence of medians. Centroid is a point of concurrence of medians. See this. So what is a median? So median is a line segment from vertex to midpoint of opposite side of a triangle, so is called median. So if you take any triangle, here it is a triangle, this is vertices of triangle and this is midpoint of its opposite sides. The line join from vertex to midpoint of opposite side is called median. What is the median? The line joining of vertex to midpoint of opposite side is called median. Here how many vertices does a triangle have? Obviously 3 vertices. So from this vertex, the line joining of opposite to midpoint is called one median. From vertex, second vertex, this is second median, and third vertex, this is third median. So obviously there will be 3 medians of triangle. A triangle has 3 medians, and these 3 medians passes through one common point. The point of concurrency of these medians is called centroid. What is this? Centroid. What is this? Centroid. G. It is denoted with a capital G. So centroid is nothing but so average of 3 vertices also. See this one, the centroid of a triangle is point of intersection of medians or average of 3 vertices. So what is average? In general you know average. Average means a plus b by 2. Here 3 vertices are there, so that average is nothing but centroid. Let us see what is the average. So here this is, let it triangle, this is vertex. Every triangle has 3 vertices. Let us take A x1 y1, B x2 y2, B x2 y2, C x3 y3. So as I said, I can draw 3 medians. One median from vertex A, let it be AD, and one median from vertex B, this is, let it be BE, and another median from vertex C, let it be CF. This is a point of concurrence of medians. The point of concurrence of medians is called G. What is G means? Point of concurrence of medians. This median will bisect the opposite side. Why? Because as I said, median means the line joining of vertex to midpoint of opposite side. Here D is midpoint of BC and E is the midpoint of AC. And F is the midpoint of AB. So this is centroid G. And how to find a centroid of a triangle? when vertices A x1 y1, B x2 y2, C x3 y3 are given. So as we know from plane geometry, here the centroid G divides the median in the ratio 2:1. This G divides the line segment AD in the ratio 2:1. Means this AD will be 2 parts and GD will be 1 part of AD. Here let us find what is the formula for finding centroid. So once see this here, what is D here? D is a midpoint of BC. Already in coordinate geometry we learned midpoint formula. So what is the midpoint? x1 plus x2 by 2, y1 plus y2 by 2. Here the vertices are B, x2, y2, C, x3, y3. Then the vertex of D becomes x2 plus x3 by 2, comma y2 plus y3 by 2. This is a D vertex. I know D vertex as well as A vertex. A is x1, y1, and I know the ratio dividing by G. Here G is dividing the line segment AD in the ratio 2:1. So by using section formula or division formula, we can find this G. Apply here. See here, this is A, this is A, this is a G, and this is a D. Okay, now this G is dividing line segment AD in the ratio 2:1. So apply section formula. If I apply section formula for A and D, I will get the vertices of G as x1 plus x2 plus x3 by 3, comma y1 plus y2 plus y3 by 3. So this is the formula for centroid G of a triangle. What is the formula for centroid? If A x1 y1, B x2 y2, C x3 y3 are vertices of triangle, then centroid G is equal to x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. That's why I denoted here G is the average of 3 vertices. Average of 3 vertices. Next, for example, here I am taking this is a G. This is G, this is A, vertex A, B, C. And obviously, what are these? These are midpoints D, E, F. D, E, F. What is the formula for G, Nana, here? G is x1 plus x2 plus x3 by 3, comma y1 plus y2 plus y3 by 3. And here, if you observe, if D, E, F's are midpoints, if I join these midpoints, I get another triangle, that is a line joining of triangle formed by the midpoints of triangle ABC. There DEF is another triangle. So if you observe here, G is centroid of ABC. Centroid of triangle ABC is G. Now, what can be the centroid of triangle DEF here? So, obviously here the centroid of triangle DEF also, centroid of triangle DEF is also the same G. Here G acts as centroid of ABC, triangle ABC, as well as triangle DEF. This is common. Centroid means average or gravitational. In general, you can see the word gravitational force. It located on at the middle of the triangle. This is G. Okay, now. So what is the formula here? x1 plus x2 plus x3 by 3 and y1 plus y2 plus y3 by 3. So here G is centroid of ABC as well as DEF triangle also. Here the triangle DEF is formed by the joining of midpoints. And another one more property of centroid. So see here, for example, if this is G means if I join GA, GB, GC, if I join GA, GB, GC, this lines divides the triangle into 3 equal parts. 3 equal parts means the area of GAB is also equal to area of GBC is also equal to area of GAC. Here you can see there will be 3 smaller triangles. Triangle GAB, triangle GBC, triangle GAC. Okay, na? All these are equal in areas. GAB area, GBC area, GCA area also, means he divides the triangle into 3 equal pieces and each is equal, and each equal to 1/3 of a full triangle, triangle ABC. Okay na? Triangle ABC is dividing into 3 parts, means each is 1/3 of whole, that is 1/3 of triangle ABC. So this is one of the property of centroid. Let us go for one example. Find the centroid of triangle. This is the formula. Find the centroid of triangle which is formed by the vertices 3, 4, 5, 12, 8, 5. Okay now. So find G. So here same, G is equal to x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. Here x1 is 3 plus 5 plus 8 by 3 and 4 plus 12 plus 15 by 3. The answer is 16 by 3 comma 31 by 3. So like this we can find the centroid of any triangle when vertices are given. Sometimes A x1 y1, B x2 y2, B x2 y2 and G also will given, that is for example let it be alpha beta. Find missing vertex C he will ask. So as you know what is G is equal to, G is equal to x1 plus x2 plus x3 by 3 na. So here means G alpha beta is equal to, what is G formula, alpha comma beta is equal to x1 plus x2 plus missing vertex let it be A comma B nana. So x1 plus x2 plus A by 3 comma y1 plus y2 plus B by 3.